All right, so in our new problem set, we start off with a first example or another example of a reactive force. So our first example was the buoyant force that we had at the end of problem set 2, and now normal force at the beginning of problem set 3. What happens with normal force is it's basically the force of a contact surface not breaking. So if an object sits on top of a surface, the weight of the object will push down, or if I walk up and like punch the board real hard and the board doesn't break, then that's why it hurts, because technically that force pushes back against my hand. This isn't going to be true all the time, because we can have things set up at angles, we can have multiple forces, stacks of things. But for our initial easy example here, our first setup, we're going to say normal force, so F for force and capital N for normal, will be equal to the weight of the object, which again is a trick we saw in the last problem set. The problem we run into is we may not have that information, right? So if we look, we need to recognize this. We don't already have the answer because these kilograms are a measure of mass. So we don't know the weight right now, but we do know that by definition, weight can come from a combination of mass and gravity. And then again, because we don't have any other context, we assume that gravity is Earth gravity, and then finally we have a way to make progress. So from the question, 5.26 kilograms of mass on Earth gets multiplied by a gravity of 9.8 meters per second squared. And then multiplying those together will give us newtons. So remember, there's that definition that we've seen. You want to remember that they combine in that way. Otherwise, there's no real direct clue for it. Then running this through a calculator, we get approximately 51.55.